Welcome back to the channel, everyone. So, in our beginners DSA sheet, today we are going to solve the next problem that is missing in an array. So, in this problem, an array is given to us of size n minus 1 and it contains distinct integer from 1 to n where n is inclusive, and we have to find that missing element from this array. So, here an array is given to us, and we can see that 1, 2, 3, and 5, but 4 is missing here, and the size of the this array is n minus 1 and only one element is missing inside this. So we have to find out that missing element from this array. So now we are going to solve this problem in brute force way, then better way, and highly optimal way. So let's get back to the notebook and see how this problem is solved. We have seen the problem statement that an array of size n minus 1 is given to us, and we have to find out one missing element from this. So here array size is 4, but the number of element is 4 plus 1, that is 5. So now we have to find that in range from 1 to 5, which number is missing. So here we can see that 4 is missing. So 4 is the output of this problem. Now try to solve this problem via brute force way, in which we have to run the first outer for loop from 1 to n because the number present inside this array from 1 to n, and another for loop from index 0 to 3, and we have to compare all the value with the outer for loop, and if it is present inside this then we have to return true. So I'm writing down the brute force way, like first our for loop run from index equal to 1 to n, that is here 5, and the inner for loop index j is run from index 0 till the last value index, that is 3. And every time we have to compare the value of j with I, and if it is equal to I, then we have to return true and break the statement. So this is the brute force way to solve this problem. Now try to dry run this code, and I is starting from 1, and we have to traverse this array for every value and check that if 1 is present inside this or not. So array 0 is equal to 1. So we found 1. So mark it true and break the statement, and again go for the next value of I, that is 2. So here we have to make one bool variable that name is found and mark it by default false. And after traversing, if it is found, then mark it true and break the statement and again check for the next value of I. And at last, if found equal to false, then we have to simply return the I value, which represent the missing value inside this array. So now I value is equal to 2. Again traverse this array. For index 0, value is 1. So it is not equal to 2. Index 1, value is equal to 2. So we found this value 2. So mark found as true and break this statement and again go move for I equal to 3. Now again traverse this array. 0 value is 1. 1 value is 2. 2 value is 3. We found this value, then mark it true and again break this statement and again go for I equal to 4. Now traverse this loop, and after traversing we are unable to find the value 4 inside this. At index 0 value is 1, at index 1 value is 2, at index 2 value is 3, at index 3 value is 5. So we are unable to find this I inside this traversal. So after traversal, still by default value of found is false. We are unable to find inside this, and now we find that found is again false, that is by default. So now we have to return this I. So we have to return 4. So this is the brute force way to solve this problem. Let's implement this brute force code. And in this brute force code, our first index I is starting from index 1, and it is run till array size plus 1 because the array size here is n minus 1. So total number of element is n plus 1, that is array size plus 1. And our inner for loop starting from index 0, and it is run till the last index. And if that element is found, then mark it true. Otherwise, it is by default false. So we have to return simply I. Now I'm going to implement this. Let's compile this. So I have made a mistake because our index I is starting from value 1. So you have to make it 1. And now again compile this. Okay. So now our compilation is over. So this is the implementation of code in a brute force way. You can solve this problem. And for this, the time complexity for this problem here is because we are using the two for loop. So the time complexity here is big O of n square. And we are not using any extra space. So space complexity is big O of 1. This is the brute force implementation. Now I'm going to solve this problem with a better approach. There are two better way approach via which we can solve this problem. The first one is hashing and the next one is unordered set. So in hashing, we have to declare one hash array of the size n plus 1. Here the array size is 4 and the n value is 4 plus 1 and we have to create n plus 1 sized hash array. So the size of this hash array is 6 and everything is initialized with 0. This is zero based indexing. That's why we are using n plus 1 size hash array. And now traverse this array and at that position mark 1. So 1, so we have to mark position 1 as 1. On second, we have to mark position as 1. On 3, we have to mark position as 1. On 5, we have to mark position as 1. And now start traversing this hash array from index 1 because 0 is irrelevant to us. That's why we use n plus 1 size of hash array. And now check that if value is equal to 1 or not. If it is equal to 0, then we have to find the index 4. And this is the way via which we can solve this problem in better way, that is using hashing. So this is the approach. So I'm writing down the pseudocode for this. So we have to use one hash array. So we have to initialize the hash array of the size n plus 1 and all is initialized with 0. And now we have to traverse the for loop from I equal to 0 till the array size, that is 3. And we have to mark hash array as 1 if there is element inside this array. And after that, we have to traverse another for loop for the hash array from index equal to 1 and it is run till n plus 1 because we have declared an n plus 1 array. And if hash array I is equal to 0, then we have to return I and this is the missing number. So this is the way via which we can solve this problem in a better way. Let's implement this using hash array. And in this, we have to simply declare one hash array and all is initialized with 0. And after traversing via for loop, mark down all the position of the hash array with 1 and again traverse one for loop and found that if any element value is equal to 0, then we have to return the index of the hash array and that is our missing number. So I'm going to implement this. Declare one variable that is missing number and find the value of n that is array size plus 1 and hash array initialize one hash array with the value 0 for every index till n plus 1 because it follows zero base indexing, and now traverse this array and mark the hash array position as 1 for every value. Like if there is 1, then mark that position as 1. For position 2, mark the position as 1. For position 3, mark the position as 1. For position 5, mark the position as 1. So the fourth position is still 0. So if there is 0 inside the hash array, then we have to return the index. So the similar thing I have implemented here. So our index is starting from 1 and we have used the 0 base indexing. That's why we are not including n plus 1. It is exclusive. And if hash array I is equal to 0, then the missing number is I, and we have to simply return this missing number. So this is the way via which we can find the missing number in an array using hash array. Let's discuss the time complexity of this problem. So here we use separate for loop, not nested for loop. So the time complexity here is big O of n, and also use one hash array. So the space complexity for this problem is big O of n. Now we can move forward to the unordered set by which we can also solve this problem. Here also the time complexity is big O of n and the space complexity is also big O of n, because here we also use the set to solve this problem. In the next approach, we are going to use unordered set because it contains distinct value, not duplicate value, and in our array we can see that all the values are distinct. So we are going to simply insert this all value inside the unordered set because it does not contain any duplicate value, and now traverse another for loop from 1 to 5 because the number lies between this array from 1 to 5, and every I we have to check the count inside this my set. Like here the count of 1 is 1, count of 2 is also 1, count of 3 is also 1, but the count of 4 is 0. So if the count of any element from 1 to 5, the count is 0, then we have to simply return I. So this is the approach via which we can solve this problem using another set. So firstly we have to declare one my set and insert all the values of array inside this my set, and now traverse one for loop from 1 to 5 and check the count of that value is 0 or not. If the count is equal to 0, then we have to simply return I. Let's implement this on code editor. Let's compile the code. Compilation is successfully completed. So this is the way via which we can use the unordered set to solve this missing number problem. Now we can move forward to the next optimal approach. There are two optimal approaches to solve this problem. The first one is mathematical logic and the second one is XOR. So in mathematical logic, we have to find the sum of what? 1 to n summation. And in another sum array, we have to find the sum of the element inside this array. And we have to subtract sum array from the whole sum. So this is the logic behind this to solve this problem. So we have to first found the sum from 1 to n. You can use the formula to calculate this sum. It's n into n plus 1 by 2 to find the sum. Here the summation from 1 to n is 15. And now traverse this array from index 0 to 3 and declare one sum array with initial value equal to 0 and we have to add all the value of this array inside this sum array. So you find the sum of this whole array. After summation of this whole array, you got 1 plus 2 plus 3 plus 5, that is 11. And now you have to subtract this sum array from the sum. So after subtracting sum array from the sum, you got the missing number, that is 15 minus 11 equal to 4. So this is the optimal approach via which we can solve this problem. Let's implement this code. Here we use one variable, that is missing number, and calculate the n value and put it inside the long because we are going to calculate the sum and it may vary from the range. That's why we are using long integer here, and find the sum and also initialize one array sum equal to 0 and traversing the whole array and store all the summation of the element value inside this array sum and find the missing number equal to summation minus array sum, and we have to return this missing number. So let's compile. Okay, so the compilation is completed here. So this is the way via which you can solve this problem using mathematical approach. Now we are moving forward to solve this problem using XOR. The next optimal approach is XOR, via which we can solve this problem. We are also called this approach a pair cancellation. The name itself suggests that how to solve this problem. So in exclusive OR, if A XOR with A, if both are same, then output becomes 0. And if we take XOR of A with 0, then it returns A. The logic behind this problem is to take the XOR of all the number of this array with 0 and also take the XOR of the number from 1 to n with the 0. So I'm implementing this. So take one variable, name is XOR number, and it is initialized with 0. Now traverse for loop from 1 to n and take the XOR of 0 with 1 and with 2, again with 3 till n. So n equal to 5. So we have to take the XOR of all this number. So it become 1 XOR, 2 XOR, 3 XOR, 4 XOR 5. Now we have to take another variable. That variable is XOR array, and we have to initialize this also with 0, and for loop run from index 0 to 3. Just index value is 3, so we have to run this from 0 to 3 and take the XOR array of 0 with index 0 value, that is 1, with index 1 value, that is 2, with index 2 value, that is 3, with index 3 value, that is 5. So it give me 1 XOR 2 XOR 3 XOR 5, because if we XOR 0 with 1, it become 1. Now we found two value. One is XOR array value and another one is XOR number value. Now we have to take the XOR of these two. So after taking the XOR of these two, one is cancelled with 1 because A XOR A is 0. 2 is cancelled with 2 because 2 XOR 2 is also 0. 3 is also cancelled. 5 is also cancelled. So 4 is the remaining value. So we have to return this 4. So missing number equal to XOR of array, XOR array, XOR, XOR number. So this is the logic we are going to implement inside the code. Let's jump into the code editor. In this code here we found the n value, that is array size plus 1, declared two variable XOR number and XOR array. Both are initialized with 0, and there is also one variable that is missing number. Now, in first for loop, we are going to XOR all the number from 1 to n with 0. So it give me 1 XOR 2 XOR 3 XOR 4 XOR 5. Now, in second for loop, we XOR all the array element with 0, and it will give us 1 XOR 2 XOR 3 XOR 5. Now we are going to take the XOR of XOR number and XOR array. It will give us missing number. So we are going to return this missing number. So this is the optimal approach via which we can solve this problem. In this, the time complexity to solve this problem is big O of n, because we are going to use one for loop here and also here, but it is not nested. So the whole time complexity is big O of n, and we are not using any extra space. So the space complexity for this problem is big O of 1. Let's compile this. Compilation completed. Let's submit this. This is the wrap up of this problem, how we are solved this problem. In the upcoming videos, we are going to solve more problem in better way. If this video is helpful for you, then please hit the like button, subscribe to the channel, and I will see you in the next one. Bye.